The 2022 USA-Taiwan International Conference on AI plus Smart Machine, hosted by Smart Machinery Promotion Office and Taiwan AI Association, is about to begin. So please be seated as soon as possible. To ensure the quality of the conference, please switch your mobile phone to silent mode. Thank you for your cooperation. Good afternoon, ladies and gentlemen. Welcome to 2022 USA-Taiwan International Conference on AI plus Smart Manufacturing. I'm Chen, the Director of Taiwan Artificial Intelligence Association and also the moderator for today. This conference is jointly organized by Smart Machinery Promotion Office and Taiwan AI Association. Today, it's our honor to invite professionals from both Taiwan and American AI industries to deliver keynote speeches about smart manufacturing with AI technology. We'll have 3 sessions composed of 1 special talk, 4 keynote speeches, and a panel discussion for today. Before beginning the exciting conference, I'd like to invite the distinguished guests to deliver opening remarks. First of all, we're delighted to invite Ministry with our portfolio of Executive Yuan, Audrey Tang, to give us the welcome remarks. Let's watch the video together.
Economic Officer of American Institute in Taiwan, Patrick Boland, Taiwan AI Association President Leon Jiang, distinguished speakers, industry representatives, and guests on site with us. Good local time. On behalf of the Executive Yuan, I'd like to extend my warm welcome to everyone in the USA-Taiwan AI plus Smart Manufacturing Conference. As we all know, Taiwan has outstanding manufacturing capabilities with a complete supply chain in the high-end technology field. American innovators, on the other hand, are well known for great R&D capabilities. Obviously, collaboration between USA and Taiwan creates a win-win situation. As of this year, throughout the global supply chain turbulence, Taiwan's industries have continued to progress with smart and flexible manufacturing. And now this year, the InnoVEX stage is promoting industrial exchange between USA enterprises and Taiwan enterprises in the topics of smart manufacturing and digital transformation. So I hope that through this conference, we can facilitate discussions between leading experts from both Taiwan and the US so that our industries can face the ever-changing international market, solidifying mutual support to make supply chains for our industries even more robust and resilient. I thank all of you for your participation, and special thanks to the experts for your openness in sharing advanced technology and applied experience in the upcoming presentations. I sincerely wish everyone fruitful and productive discussions and a very successful event. Thank you for listening. Live long and prosper.
Thank you, Minister. Now it's our pleasure to invite the economic specialist of American Institute in Taiwan, Dr. Da-Ching Shi, to give us his welcome remarks. Ladies and gentlemen, now please join me in welcoming Dr. Shi.
在场各位的好朋友先进，各位好朋友，大家好，我是 AIT 经济组的大庆，今天能代表 AIT 来这里啊，其实就是因为我们 AIT 里面有 AI 嘛 ，OK， 没有，其实是因为小梅的关系，她是我们多年 AIT 的好朋友，从以前的 Startup Community 到现在整个 AI Community 都是跟我们有许多密切的合作。我这边大概看一下今天的这个论坛主题是 AI Smart Manufacturing， 所以它的重点应该是在 Smart Manufacturing and AI。那 Smart Manufacturing， 因为我业务上所及，所以我觉得这是一个所谓千年一遇、千载难逢的机会。因为我们都知道半导体有摩尔定律，摩尔定律18到24个月，电晶体的密度容量就要 double。可是智慧制造这个机械产业它没有这么快的一个进展，它通常一个 generation 需要大概5年以上的这个科技创新。但是今天有这个 AI 的加持，它是一个千载难逢的机会，它会产生所谓破坏式创新。所以我也很期待，稍晚的各位先进讲者 的分享。那另外在 AI 的部分哈，我们都知道 AI 其实历史很悠久，它大概从1950年代的 Dartmouth 会议就定义了 AI 大概是什么样的基本原则跟概念，但是后来它就慢慢的沉寂，直到最近又重新这个复出的江湖。其实有一个很大的原因是因为我们有足够的 data。其实人类现在一天产生的资料量，大概是可能90年代、80年代所有过往的累积的加总，还不够我们最近这一个 decade 产生的资料量。因为你看，每个人都有一个手机，手机可以拍照，每个人都有很多 wearable device， 它可以收集很多的 data， 然后再加上5G 这些很多这个所谓的 connectivity， 它的连接产生的效应，传输的速度都非常的快速，甚至近期也有许多低轨道卫星，大家看到乌俄战争就知道说，连这个天上的卫星通讯，所谓的5G、6G Plus， 它都让整个这个世界非常产生的连结。那另外我们必须要知道说，人工智慧 AI 不是很可怕的事情。其实我一开始也不了解什么是 AI， 虽然我在 AIT 工作，但是我看到我的小孩从出生到现在的成长，我就知道说不用担心，人类不会被 AI 吃掉，不会被 AI 打败，因为我们的是真正的智慧，在 AI 上面它是人工智慧，所以其实 AI 是来协助我们人类精进我们所谓的 industrial AI， 在智慧制造、智慧医疗上面有许多的应用，而这2块也是目前全世界主流的趋势。大概 AI 可以在实际的应用方面，大概是能做到哪一些事情？其实这个东西很简单，就是我们现在刚刚提到有很多的资料收集，它喂养给 AI， 透过演算法持续不断的精进。以后它就会有更好的 AI 的结果，它可以协助我们在包括深度强化学习 Deep Learning， 包括大数据分析 Big Data Analysis， 还有视觉影像的分析，所谓 Visual and Recognition 等等，还有甚至 Blockchain 的技术，这中间 AI 都可以辅助我们人得到更正确的判断，做出更好的有效率的结果。那AIT 到底在 AI 上面有做什么呢？不是因为它刚好是有 AI， 也不是因为认识小梅，而事实上呢，美国政府在 AI 上面有2大的倡议。第一个是 GPAI Global Partnership on AI， 这是一个美国与 OECD 国家共同合作的倡议，它希望强调的所谓的 responsible use of AI， 因为我们都知道，可能包括中国或是一些其他的国家，它在使用资料的时候，它是不管隐私的；它在应用 AI 的时候，它也不尊重人权的。所以有这个 Global Partnership on AI， 大概就是美国与 OECD 国家，我们也有台湾也有在美国的协助下，台湾也有参与 GPAI， 这是第一个国际多边合作 AI 的组织。那第2个呢，是美国最新的倡议，叫做 AI Connect。AI Connect 它希望的就是全世界几个 AI 主要的领导国家，美国自己拿出国务院有拿出许多的 funding。那我们在 AIT 在台湾也有与包括科技汇报，包括与经济部，还有一些学界的老师们，包括台大的老师，在不管是刚刚讲的 responsible use of AI， 另外还有就是在探讨 AI law and ethics， 就是所谓的人工智慧法，还有它的道德面的问题，也是再次希望就是透过比如说 federated learning 等等的方式，让 AI 不会去对人类产生任何的坏处威胁。于此之外呢，也可以做出更好的贡献，相较于那些不尊重 AI 人权使用的国家。所以以上大概是 AIT 为什么今天会来参加 AI Smart Manufacturing 的原因。再次感谢大家，谢谢。
Thank you, Dr. Shi. Please return to your seat with extra care. Now, I'd like to invite the chair of Taiwan AI Association, Dr. Leon Zhang, to give us his warm remarks. Let's welcome Dr. Zhang to the stage.
Good afternoon, ladies and gentlemen. It's my pleasure to welcome our honorable guest, Economic Officer of American Institute in Taiwan, Da-Qing Shi, Industrial Development Bureau, Minghuan Zhang, Division Director of Industrial Technology Research Institute, Su Huang, Solomon Technology Corporation, Johnny Chen, Techman Robot Incorporated, David Huang, Landing AI, James Chen, and Rockwell Automated, Jack Wang, distinguished speaker and industry representative. Welcome to everyone. Today, I'm honored to join the USA-Taiwan AI Smart Manufacturing International Conference. First, on behalf of Taiwan AI Association, the TAIA divides the development blueprint of Taiwan's AI field into 8 areas, including smart manufacturing, smart healthcare, smart finance, smart retail, smart agriculture, smart education, unmanned vehicle, and cross-domain integration. In the future, the Taiwan AI Association will continue to promote industrialization of AI and expand application of industrial AI with the theme of combining the field side with the equipment side. AI will be introduced into the mechanical equipment industry, such as machine tools and robots, to add value to equipment, drive machinery, and the industrial competitiveness of manufacturing industry. Since 2020, the world is facing the impact of epidemic on the supply chain, and the industry needs to continue to improve so that the industrial supply chain does not suffer from the disruption. It is believed that the conference will help to establish a complete industrial supply chain and become a global smart manufacturing base. This year, especially in the InnoVEX stage, is promoting industrial exchange between American and Taiwan companies in the topic of smart manufacturing and the digital transformation. Finally, I wish US-Taiwan AI Value-Add Smart Manufacturing Seminar to be successful in enhancing international connection, promoting technical operation, and exchange business opportunity. Finally, I wish everyone participate will have a rewarding experience. Thank you.
Thank you, Dr. Zhang. Please return to your seat with care. Without further ado, now we'll start the first session of a special talk by Dr. Shu Huang, Division Director of Institutional Technology Research Institute. His research interests are in the areas of robotics, advanced motion planning, CPS system, medical robotics, and biosystems. The novel software-defined joint module by Wang the R&D 100 Award in 2021. His goal is to provide value-added robotic technology to the industry. Please join me welcoming Dr. Huang.
Wait, hi. Hello. Good afternoon, ladies and gentlemen. The title of my today's presentation is Advanced Robotics Technology for Smart Manufacturing. My name is Shu Huang, and I'm the Division Director of Intelligent Robotics, ITRI. Okay, again. So let's talk about ITRI. ITRI Robotics is one of the biggest nonprofit research institute focusing on robot technology. We established in 2005. In the beginning, we start our focus on the service robot. As you can see here, we have developed cleaning robots, and tour guide robot, companion robot, and security robots. And from the year of 2010, we switched the focus to the industrial robots. We cooperate with the companies in Taiwan to build manipulators and AGVs. And we put the research focus still on the controller. And in the year of 2015, also as the trend of Industrial 4.0, we see the trend of the software in robotics. So we developed our own simulator, and we combined the mobile platform with the manipulator to autonomous mobile robot. And now we tend to provide a total solution to the industrial as a robot cell. So let's take a look at AI robots. The goal of AI robots is that robots can have the capabilities to perform human skills with manufacturing domain knowledge. To do that, we should first digitize human skills so that we can have more data. And by analyzing this data, we can transfer skills from human to robots. So robotics is actually an enabler of the digitization for smart manufacturing because robots are flexible and adaptive manufacturing platform. And by adding more sensors, we can know the environment more, and we can know the condition of our working condition. And then the simulator can deal with the data and to have a digital twin for the cyberspace. In the end, with the machine learning and AI techniques, we can transfer and allowing robots to learn the skills from humans. So this is a process of acquisition of manufacturing skill. An AI robot can perform tasks that require skill learning and experience, and AI robots can cope with uncertainty in minimum human intervention. So the core of this AI robot relies on our robot controller. So we have an EMIO robot controller. MIO stands for the Motion Intelligence Orchestration. It can connect to most commercial robots and providing an open architecture to the simulator. And we provide also the RCL motion libraries, providing a true motion planning and dealing with singularities and obstacle avoidance. We have velocity and torque command control mode, so we can program the robot to have more advanced human-robot collaboration. And this controller is purely EtherCAT interface, so we can easily connect other sensors or devices. Of course, we have advanced modules that deal with accuracy improvements and safety. So let's look at the CPS concept. As I said, the EMIO controller can deal with the low-level connectivity with the robots and the devices and the sensors and the physical part. And then we convert this data and information to the cyber world, in which we have easy simulator. In this simulator, it's just like playing games. We can import CAD models and do the robot planning and robot simulation in this simulator. And then we also provide a lot of robot models and devices for the users. This simulator also have a physics engine, so that mimic the gravity in the real world. Combine these two, the physical world and the cyber world, we can have a CPS system that this system applied on the manufacturing process, such as grinding and polishing, cutting and weaving, and painting, etc. So the vision-guided robot is our first example for the CPS concept. So in this case, it's a random bin picking, in which an object, there should be a video. The object is placed randomly and in stack in a place. The mission of the robot is to recognize each object and then properly pick it up. So it's like the human operator. So to do that, we need to create a model of the object. And in the simulator, we simulate different postures from position, angles, and lighting, etc., so that the robot can learn how to pick an object properly. The second example I want to show is the robot grinding system. This work has been done nowadays by human laborers in a very dirty and noisy environment. If we want robots to help them to replace their work, we can introduce this CPS grinding system to the metal work. So to begin with, we establish a system configuration in simulator. So as you can see here, we have the robot, we have devices, and we have object there. And then from the robot simulator, we simulate the physics, virtual forces, and contact vibrations, etc. And in the middle of the loop, we just use the machine learning techniques to make the robot find the proper way to grinding the object. And in the end, we send the optimized result to the robots in real world so that this robot can perform grinding process. So this is how an AI robot can learn skills from human. On the other hand, we also add another feedback loop, which is the quality assessment loop. For this purpose, we need to consider also the quality of the object and then make a feedback control as a cost function to do the process optimization. So we can, based on the performance of the quality, and then change the parameters, also the wheel speed and the robot pose to increase a better quality. So that's how that's the block diagram of how we cope with the AI robotics. So in the end, we have a better result. Our CPS system can automatically generate a trajectory, and we can have less tuning time and a better grinding quality. So this is, okay, so this should be the video. So in this video, we just showing that if we, okay, thank you. If we collect enough data to the simulator, and if we simulate the world as real as possible, we can predict what will going to happen. So in this case, our simulator predicts the movement of the robot, and we also know how to perform a better robot grinding task. We call it phantom simulation. It's very cool. And the last example is the AMR navigation. So our email controller controls the mobile platform together with the manipulator on top. And the cyber part is easy SIM that sends the data from the environment, so we can build a map of the environment, then perform navigation. So this AMR example can be used for industrial applications, such as logistics in factory and auto forklift applications, even to detect the high power plant. And in service applications, we can make this robot to pick up staffs in convenience stores, and also disinfection in hospitals, and also doing cleaning tasks in airports. So the conclusion that we believe that applying robotics to smart manufacturing is inevitable, and the robot actually is an enabler for digitization for smart manufacturing, because robots are being flexible and adaptive manufacturing platform. And by adding more sensors, we collect data from manufacturing or the data from environment. With the help of CPS simulator, we can planning, we can optimize, we can deal with uncertainty in advance. And with the help of artificial intelligence, machine learning, and data-driven experience can be collected. So I have shown you the 3 examples, including object recognition, like random bin picking, and CPS robotics grinding system. And last is the distributed path planning for AMR. That concludes my talk today. Thank you very much.
Thank you, Director Huang, for your informative sharing. Please return to your seat with extra care. Now we'll begin the second session of 4 keynote speeches. The first 2 speeches will center on data-centric AI applications on smart manufacturing, and the rest 2 speeches will be about automated factory management. The first speaker from Taiwan is Johnny Chen, Chairman of Solomon Technology Corporation. Today, he will talk about AI applications in manufacturing and logistics industries. Let's welcome Chairman Chen to the stage. Chairman, the floor is all yours.
Hello, good afternoon. It's a pleasure to speak here about this exciting and very important topic. I want to talk about the applications of AI in manufacturing and logistics sectors today. More specifically about AI, how AI empowers machine vision. As most of you already know, AI is part of our lives. From Amazon Echo to a lot of different apps we use on our handset. So what are the potential applications for AI in industries? I'll talk about that in a few minutes. But first, a little bit background about my company. Solomon was established in 1973. It's public listed in Taiwan. And we have been doing this automation for the last 10 years. And AI, I believe, since around 2014, 2015. So we have been doing this for 6 years. Next slide. These are some of our customers using our AI solutions worldwide. Includes a lot of top 500 companies in the world. Next slide. And we rely on our sales offices and our distributor SI networks worldwide to promote our product and to do a lot of system integration works. Okay. And these are some of the awards we won in overseas, in the US, in Europe, as well as locally here in Taiwan. So how can AI help manufacturing and to a certain extent logistics industries? It turns out there's plenty of things we can do with AI in factory floors and in warehouses. There are 4 things I want to highlight today. The first one is something the previous speaker just alluded to. It's random bin picking. It's basically material handling. Second thing is vision-guided robot. And third is inspection. And fourth is a latest innovation we have. It's something we call a wearable AI. Okay? I'm going to talk briefly about each one of them. Okay? First one. The 3D robotic material handling is an interesting development over the last decade. Traditionally, robot can only be programmed to run fixed routes, which means it's actually quite dumb. If you think about it as a person, it's like a person who cannot see anything. With a vision system, especially one powered by AI, it's able to see a lot of complex patterns that's otherwise not possible. Okay? So in the next example I will show, this is in one of our European customers' factory. It's actually based in Germany. It's an automotive part component maker. It's basically doing something called kitting. It picks different parts that comes on a conveyor line. And the AI system will have to recognize which part it is and put into this cart that basically keeps on moving forward. Okay? Now, this uses about 13 of our vision systems combined with 13 ABB robots. Okay? Okay, next one. In a more complex setup, this is actually the world's first multi-robot bin picking system. It is a first because it uses AI not only empowering the vision, but making sure multiple robot arms working on the same cell do not collide with each other. Okay, so we came up with this because we had some logistics customers who figure that one robot by itself is not fast enough. So it requires multiple robots. They actually require, I believe, 18,000 parcels being picked per hour, which is about 2 seconds per pick. So that's very fast. And we needed 2 robots to make it work. One robot was not fast enough. Okay. The second application, and this is something that a lot of young people don't want to do these days, is things like gluing, welding, deburring, things like that. And how can robots help here? A robot can Let me actually use an example here to show. In this particular scenario, this is in a car factory. You can see an auto body comes to the station where the robots, the cobots down there, is going to glue the car body. But the problem is the yellow frame that comes, every time it doesn't come to the same stop, and the location can vary quite a bit. So if you use a robot, you just program a robot to let it run, it's not going to do the job, you know. So here we rely on that scanning, the 3D scanning you just saw. One simple scan, our software take over, and it will tell the individual robots where to go to complete this task. In this factory, there are already multiple units being in use to do this kind of auto body gluing. And same thing for a lot of welding applications, you know. So basically, the vision system can smartly guide the robot how to do the jobs very flexibly and intelligently. The AI system doesn't just have to go with the robots. One of the most popular applications we have used our software with is inspection. And we have done this with a lot of semiconductor companies, electronic component companies, non-tech companies here in Taiwan, including shoe manufacturer, textile companies, contact lens makers. They all use the AI system to inspect defects in their production lines. In this particular case, we have a chicken nuggets, McDonald's chicken nuggets. So these things are running down the conveyor about 20 centimeters per second. And there are multiple types of defects here. You have coloration defects, you have nuggets that's peeled, and also several nuggets stuck together. And then our AI system will have to identify this type of defect real time. And then after it identifies, it has to create a log file or statistics about number of each defects. And then it has to connect the robots later on in the production line, which ones are defects, and the robots will have to pick out the defective nuggets. Okay? Sometimes customers don't always have a lot of defects. So when they don't have a lot of defects, they ask us a question: how can we just use a good sample to know which ones are defective? So in this case, you can see you have a golden sample PC board, and then using only a good sample, only 15, 20 images necessary. It can learn what's good, even though it doesn't know what's bad. It can tell you on the right-hand side which PCB is different from the good one, and where is it different. You know, there are certain customers in electronics industry relying on this type of inspection. The next one. The last one I'm going to introduce is what we have done most recently, and it's currently being patented right now. It's we are putting AI on wearable devices, such as AR glasses. Okay, so you may ask, why do we need to put AI on AR? It turns out there's a lot of applications you can do with this. For example, putting on AR glasses here, a person, the AR glasses as camera, can go to an electric panel, and then you can see in real time what's through the stream of images coming out, and then the person can see, okay, so what's going on with this electric panel I'm seeing right now? Does it have any error in terms of misplacement of the cables? And the AI feeds back the real time to the AR glasses, and the person. So basically, this is augmenting the human vision, so that people don't miss anything when inspecting some things. Okay. This is another example. This is inspecting of chemical trucks, to make sure they are parked in proper place. And you might ask, why do you want to do this? Because frequently people just don't inspect properly, or they simply don't inspect at all. And this allows the management to keep track all the things are done properly. Basically, SOP, standard operating process, validation. So this is very important as well. And so right now in Taiwan, there are a lot of companies asking us for this kind of systems, okay? That's basically a very quick rundown of the applications we are doing with AI. Thank you very much.
Thank you, Chairman, for this outstanding presentation. Please return to your seat with extra care. Now, the second speaker from USA is Kai Yang, Vice President of Product from Landing AI. Established in 2017, Landing AI focuses on manufacturing visual inspection. Kai's team is responsible for the Landing Lens product vision and development. He also oversees the product roadmap and works very closely with our strategic partners. Now let's welcome Kai to share with us online about using an end-to-end workflow to build and develop AI-powered visual inspection solutions. Let's welcome Kai.
Hi, it is a pleasure to be here, sharing our experience on applying AI in manufacturing. My name is Kai. I'm from Taiwan and now running the product team in Landing AI. In Landing AI, we have developed an end-to-end deep learning-based computer vision platform that helping our users to develop and scale up their computer vision applications. I would like to use today to share our experience on this and how we apply those end-to-end platform in the visual inspection world. Oops. So let me quickly introduce our company, Landing AI. Landing is founded by Andrew Ng in 2017, right after he left Baidu. I think everyone knows about Andrew, he founded the Google brand and leaded Baidu AI team. So during his Google time and Baidu time, that Andrew realized one important thing is that large internet company giants like Google, Baidu, Amazon, Facebook, they are all able to apply AI to generate business value for them. For example, they apply AI recommendation, right, search, personalized advertisement. However, he also found that outside those internet giant company, AI adoption rate is very low. So the vision of his vision and Landing's vision is to build tools to help other industry, like such as manufacturing, medical, to use AI to generate business value. So one thing we did inside Landing is to build a computer vision platform to enable our customer, our friends, to be able to develop, deploy, and scale up their computer vision application using deep learning. So when we look at manufacturing industry, one application we look at first is visual inspection. Right? Visual inspection is one of the most obvious target for deep learning, for AI. Right? The goal for visual inspection is in the manufacturing line like this, in many cases, people put a human there to inspect the product, to decide the product is good or bad. Right? The obvious solution is to put a camera and put an AI model there to repurpose the human to make this decision. And as we have seen all the buzzword in AI, right? Computer vision help driving self-driving car. Computer vision can do a lot of face recognition. This putting a camera in the manufacturing line, helping visual inspection does not seem very difficult. But the reality we found that is not. Based on our experience that we did for Landing for the past few years, as well as we work with many industrial companies, we found that only 25% or less of those AI projects in visual inspection are really go live. When we say go live, means those projects are in the production line generating business value. There's a lot of POC there, but very, very few are making really business value. So why was that? So we conclude there's two major challenges that why today the AI-based system does not yet popular in the manufacturing world. But the first one is the AI system today we have is not sufficiently accurate. That means the accuracy level, either the precision or recall, that does not hit the bar that manufacturer needs. The reason can be from many things, but what mostly we see is insufficient number of data or the low quality data. And we'll come back to that. The second challenge we see for not having the AI to deploy in the production line is the AI system that need more than just the machine learning code. the Python code, the PyTorch, TensorFlow code, right? To bridging the gap between the proof of concept, POC, and the production that actually requires a significant amount of software and also the power infrastructure. A lot of people in the manufacturing forgot about this gap and start with POC. So how do we deal with it? So let's look one by one. The non accuracy. So when we look at AI system accuracy, right, we look at two things. One is the model, right, the neural net, the algorithm that contribute on making the decision. But at the same time, we look at the data, like how the data used to train the model. So I think it's safe to say in most of the computer vision application, the model itself is pretty accurate enough, sophisticated enough to get the job done. So the main problem is on the data. So when we say the AI system did not meet the accuracy requirement, a lot of time the problem is on the data. Let me give you one specific example. For data, right, the insufficient, not enough data is one problem. Here's one specific case we did. Early last year, Andrew was given a keynote speech at Automate Forward show in US. Right, one question we do in live is we ask the participant, how many images do you typically have for one defect type in your production line? And the people sitting in the conference are mainly the owner of the manufacturing line or the people who is responsible for the quality. Surprise to everyone that more than 50% of the people told us that for each defect, they have very, very little data, even less than 50 images. So this is very, very different than what we have done in AI in different world, right? In self-driving car, in face recognition, which we have millions of images. For visual inspection, we have very little. To make things worse, we also noticed that a lot of the data not only does not have enough data, the data quality is bad. When we say quality, it can be not clear images or just purely the label of defining what is defect can be misleading. For example, this is a pill, this is a painkiller pill that we ask people to label, right? You can find that one people felt that this is a defect and the other people felt that it's a different defect. Or the same pill, people have different way of label the defect or like totally different label the defect. So the challenge is that without consistent data, along with a small amount of data, the AI system just cannot get to the precision or recall, the accuracy that the system need. So you might ask that, is that really true? Is that in the world really have a lot of mislabeled data? I can tell you that even for the most famous computer vision data set that we use at school to do research, have more than 20% of the mislabeling in that case. For you who are familiar with ImageNet, you probably do not know that there are more than 100,000 of mislabels in the ImageNet. Imagine, right, how this can be amplified in the real world application that you are doing. So I want to show a really quick example how this data one can be important. So this is one example we did try to do a steel sheet manufacturer inspection, right? The customer has a very high accuracy required for 90%. Today we can only get 73%. So what we did is actually we found that by cleaning up the data, just making sure everything's consistent, using the right tool to clean out data, we can get very, very good accuracy in a very, very short time. Compared to really messing up the model, right, we can get a much, much better ROI. So if you follow Andrew, you know this is a data-centric approach that we are doing. And the platform we are building is help our customer to executing those very systematic approach to engineer your data, especially in the very small data set environment. The second challenge I want to touch is the system, right? AI system is more than the code. I want to jump in. I think one important thing we found that most of research today talk about AI is really on the model part. If you look at the past 5 years, the research paper, only less than 1% of research are talking about data, how to build a tool to enable good data for the model training and AI system. It turns out the problem is that right, every time when we do a project in the production line, when the system does not work, people look at the model, right? How can I find a better model? How can I find a better optimizer and training parameters? Instead, a real AI system actually contribute many, many steps from define the scope, collecting data, training model, all the way to deployment, and iteratively iterate data based on the training result and based on the deployment result. So you can imagine that to support this whole life cycle, that you need a big software stack, right? Like this. Like I said, most people focus on the ML, the ML code, right? The Python code that in the system. But to support the system, actually that the whole ML code only contribute 5 to 10% of the workload that we need to build. So with that, Lending, actually we build a whole system to help our customer end-to-end system, from data collection to model training all the way to deployment within one system, and they help us and our customer successfully deliver many, many projects. I want to end this one, hopefully take a key takeaway for you guys, right? For AI project, one thing we start small, and then always apply the data-centric approach that to help refine your data, you get a better model result. The third one is having an end-to-end platform really can help you and your team to manage the AI life cycle much better. Thank you. Looking forward to see you guys later in Taiwan.
Thank you, Kai, for always giving us so many new ideas. Our third speaker from Taiwan is David Huang, the manager of Vision Business Department of Techman Robot. David received his PhD degree in electronic engineering in 2007. Then he joined Industrial Technology Research Institute as a research focusing on computer vision and machine learning. His topic today is about cobot with AI vision. Let's welcome David Huang to the stage.
Good day, everyone. It's my honor to be here to share this topic to you, cobot with AI vision. And I'm David Huang from Techman Robot. And right now, I'm responsible for the vision and the AI R&D and the business. Okay, the main product of Techman Robot is this robot, just look like this one. The most significant feature of Techman Robot is that we have built-in vision system with the robot. I think most of the robots, they don't have vision, and we make it special. We put the camera inside as a built-in sensor. Okay, so today I would like to share about why and how a robot with vision plus AI can help your factory smart. When you think about industrial robot, here some picture might pop up in your mind that starting from like machine tending, welding, low on low. Most of these tasks are quite dangerous and not suitable for human beings. Most of them are quite dangerous, like dirty and dumb. People don't want to do that, and you always put a cage or a fence to separate your robot and human. But like in the 10 years ago, there's a new segment of a robot. We call it collaborative robot, or short for cobot. It was decided to work with human. Here is in the wiki, it say, this woman is decided to work with human directly in the same space. You don't need to put a fence or cage between them. It means this kind of robot, when you design it in the software or hardware, you need qualify some safety certification to make it safe to human. It will not hurt human. And based on that, we added a lot of features on this kind of robot, like hand guiding or intuitive user interface. And in Techman, we put a vision with a robot. So what a benefit that a robot with vision can brought to our customers, image like this one. In a traditional robot, when you want a robot go to the P1, P2, P3, these points on the table, you teach these 3 points on the robot base. Think about it, if the table or the robot moved, you need to reteach all of the points. But if the robot with vision, you can put a pattern on the table and create a vision base on the table, on this pattern, and then teach all these 3 points on this pattern. And even your table are moved from the robot and move back away. You just use the vision system to recheck the pattern, and all of a sudden, all the points can be updated. Here is a real case in our customer side. There's a robot to serve like 72 testing machine. Imagine if you are an engineer to set up this automation station. You need to teach every working point with this robot. You need to teach 72 testing machine. It may cost you like half week to 1 week. But our customers put a lot of visual pattern on each testing slot. Then he just need to teach one and then duplicate all the points on the others. So it's just reduce their time to like 20 minutes. Okay, so your user vision can make this kind of stuff very easy. And recently, our customers have given us a lot of feedback, like the use vision for precision is very, very, very useful. But can they use our vision for quality control or defect inspection? And the answer is yes. Here's a real case in our customer side. Before that, they use 1, 2, 3, 4 cameras to watch their product. They produce electronic device, put in a color box. So they need to use camera to check the like printing, like label, like OCR, like a barcode or seal sticker to check to make sure everything is okay before shipment. But this is a typical small volume, large variety production line. So it means they change their product quite often. So when they change the product, they need to readjust all the camera. Maybe they need to adjust the position of camera, the lens of camera. So it takes their engineer a half day to 1 day for the order change. But they change to our robot. When they change their production line, they just change another project, and then all of a sudden the robot can start work. But to deal with more and more difficult defect inspection tasks, something like random scratch, traditional machine vision is not good enough, so we need an AI. But you cannot expect the engineer in the factory, they can use TensorFlow or PyTorch, they can program Python. It's not possible. Our customers, they need a tool to help them to use AI. So this is our scenario to help them to use AI. Okay, sorry, I make the wrong project, but I try to explain I make the wrong picture here. The idea is that we use our robot to collect image and put image to our training server. Here is a web service here. User use their laptop and use their browser to log into this server and find a picture, annotate a picture, tell the computer which one's good, which one's bad, and then press button, start training an AI model, and then deploy the AI model to the end device, just our robot, and the robot can start inspect objects with AI. Here's a rare case in our customers. The customers is a branding automotive manufacturer, and this is their final assembly check station. They hang 4 of our robots on the ceiling and then put like around 18 stationary cameras on the side or back and front of the car to see everything of the car, including like engine hood, the front seat, back seat, control panel, your logo, lighting, or tire and tire frame, everything. They use this vision to check like 120 vision check items within 80 seconds. And here's a video I like to show you about this case. Here you see they hang 4 robots on the ceiling and use lots of camera for different inspection. And the robot carrier camera can see the object from different angle, different distance to check everything. And to deal with difficult inspection tasks, we need AI. For example, I think to check the type of your control panel, to check the type of your seat. And most important thing that our customer wants to save all the image in their database for product traceability. So we have another image manager system to help them to store all the image, and they can retrieve, they can get the image back, even the car has already sold out to a customer site. And we found that AI really can do a lot of things, a lot of inspection things, like, for example, from assembly check, from material classification, to anomaly detection, for counting inventory, and some random defect like scratch, dent, dirt detection. All of them, AI, you can use AI to do with that. And I want to use these slides to conclude my talk. In the past couple of years, people use robot to pick things. But with the AI and vision system, robot not only pick things, but also can pick defects. So I will quote a Taiwanese phrase, say, 電腦嘛經圖導. It means computer is good enough to pick good peanuts from bad ones. Okay, so right now it's the right moment that the robot is smart enough to make your factory smart. Okay, that's all my talk. Thank you.
Thank you, David, for the informative sharing. And let's give him a nice round of applause. The fourth speaker is from Rockwell Automation, an American company that dedicates to industrial automation and information. Today, it's our pleasure to invite Jack Wang, Manager of TC Application Development at Rockwell Automation. Jack leads the consultant and project delivery team to help factories execute digital transformation. Let's welcome Jack to share with us about how to construct and implement the plant with digital transformation strategy.
Hello. Okay. So today I'm going to share how to construct and implement the plan with digital transformation strategy. So the keyword is strategy. We have been helping the local Taiwanese manufacturer to architect the digital transformation strategy, to help them to build the roadmap and to land those digital transformation strategy. So I'm Jack Wang. I come from Rockwell Automation. We are a company focused on information and automation for more than 100 years. Okay, so there are some key drivers that push the local manufacturer to implement the digital transformation, such as like aging workforce. I would like to share, last week I was in a chemical plant. I has been told that in the plant, the average age is 52 years old. 52 years old. Can you imagine that after 10 years, 50% of them are retired? How can they find a new young face in a plant? And how can they inherit the experience? So without the digital transformation process, it will be very difficult for them to sustain. And also we can see that IT and OT convergence, it is extremely difficult because in the past few decades, the factories, they implement like automation system, MES, POM, and ERP, etc. There are more than 10 systems in a single factory. How can they integrate data from different systems? It will be a very difficult topic for them. And then most of the equipment is more than 20 years old because when they build a plant, it will be like 25 years ago. So how do we maintain those obsolete equipment to make sure the asset has been fully utilized? It's a very difficult thing for most of the plant manager. So here, we will help customers to do this. We will help them to do the consulting, to do the real-time information, and to unlock the power of real-time information. The differences between the industrial AI and the commercial AI is that the real-time information matters. How to make the data into information and consolidate those information into knowledge to help the customer to increase the asset utilization, to make the environment safer, and to improve the operation flexibility. So it will be a tough task. You must have a right roadmap to do that. So in the past, we will have analyze the historical data to find out what happened and how did it happen for the plant. So we will provide like a descriptive analysis and diagnostic analysis. Nowadays, we have like predictive analytics. we can know what is going to be happen. And in some semiconductor fab, they can use some future action to predict what should they do in a near future. And Rockwell has been done is that we have helped some customer with AI control. So we can write back the AI information into our controller. It is a very difficult job because a lot of AI supplement decision is not 100% right. So we need to evaluate what kind of action should be right back to the control system to make your factory can sustain to a different kind of circumstances. So what do we found in the factory? Many of the engineers may say they need more data, they need sensors, they need more data to do that. But what we found is that the thing is that it's lack of connectivity, not data. Because the fab has been being built for more than 20 years, there's a lot of sensors there, but it will be very difficult to integrate data from system to system. And most of the engineers, they do not understand how to access those data. And then they don't know how to transform data into useful information. So although there's everywhere, data is everywhere in the plant floor, it will be difficult for them to use. And then the second challenge is that not everyone in the plant are data scientists. So in our perspective, if you want AI successful in your plant, you must have these three kinds of people. First, domain knowledge. You must have some process engineer, and they understand what is going on in the plant floor. They understand the process. They know what is going on. Second, you need an automation engineer. They need to do a very strange analysis. They know how to make the process automated. And then you need the data processing. You need someone who is the AI expert, know how to operate the data. But the difficult stuff is that it will be very difficult for them to find a single person who carry those three capabilities. So now this is a dilemma for the factory. So what will be the solution? The solution is that I think now the plan they are doing that, they're building the standardized data platform that enable everyone in the plant. So this kind of data platform, it will standardize the way they utilize the data. So like a single facility engineer, they may have some knowledge, but they don't have the skill to process the data, but they understand automation. So with this kind of platform, we can help them to enhance their capability to upgrade your workforce through this kind of data platform. So the data platform includes a lot of stuff here. You can see you need smarter devices, you need like intelligent package power, you need a process solution, you need MES, you need a lot of different kinds of systems. So this is where we call that IT and OT convergence is important because you need to integrate like different data from different layers, and the different layer data, the format and the way they acquisite the data are very different. So this is a traditional way we will see in the plant floor. When the top management decide to integrate the MES and the ERP, they will send two groups of people that focus on this kind of application. And then they need to do it again on ERP and the POM integration. And then they're doing it again and again and again, and your system will be like this. So this kind of system will be very difficult to grow. So if you want to implement new application, it will be extremely difficult. So nowadays, I think most of the companies, they adapt this kind of solution. They use a single IT tools. They use a standard way to connect different systems and build application on it, which can simplify the structure and unify the interface and provide higher expandability and lower the O&M cost. So here's a takeaway. If you want to unlock the valuable data in your plant floor, you need to unify your infrastructure, and you need to make your stakeholder in different area to work together and to improve your decision making. So if you provide a better bottom line, then you can do that. But I think the most difficult thing is not that infrastructure thing, it's the culture stuff. Because most of the workers in the plant floor, they don't believe that digital transformation can bring the benefit to the factory. So the strategy will be this. The best strategy is that we just make some key application become a high lighthouse application that can we can help the plant floor to solve a problem, and which can be repeated to every plant. So here we will share some application that can help you to develop in the plant floor. So like this kind of asset performance management, like I said, most of the asset in the plant floor is more than 2 decades. So how do we evaluate the performance of it? So you need some AI technology, and you need some way to evaluate it. And also like ESG topic, how to evaluate if you are utilize the energy in the right way, is it efficient enough, or how do we trace the carbon footprint? And also like a digital twin. There's some way we can use the AI to recognize the environment and do the like O&M. So if even a new worker, they don't have any experiences, they can use this kind of system and to find the best way to help them to do the job. And also, like we can recognize the pipeline and the machines and tell people how to deal with that. And also like a predictive maintenance. There's another thing we can do with AI to reduce the complicated process. And after we connected all the systems together, cybersecurity is a very important issue. So we can help them to do that. So the key takeaway is that for digital transformation journey, we need to think big. To think, how would you like your company make decision in the next decade? And we need to start small. We need some lighthouse project to prove it will be successful in the future. And those lighthouse applications need to scale fast to help you to impact to your enterprise. Thank you.
Thank you, Jack, for the comprehensive presentation. So without further ado, let's move on to the last session for today, the panel discussion. So while the staff are quickly arranging the seats, may I invite all our panelists to come to the stage. So I believe that all of the audience look forward to hearing more new ideas, information shared by our experts from Taiwan and American AI industries. Gentlemen? Good day, all. In this session, I'll ask a few questions and invite our panelists to share their perspectives respectively. So in general, I'll ask from my left-hand side. So it'll be Director Huang first. So Director Huang, so in your opinion, how do we evaluate the value of smart manufacturing?
Okay, that fast. So thank you. For the first question, I think the smart manufacturing compared to the traditional manufacturing, the differences are the production line can not only produce one type of product, it can support manufacturing for multiple products, and also it's easier to change. I think it's a kind of return of investment. So if you introduce the smart manufacturing, so you can have a manufacturing line that can produce more than one type of product. For you, it's better, and you have more flexibility of different order. For example, like a robot, AI robot. If you buy a robot, it's a welding robot. So for the lifetime, this robot can only be used for welding. But if it's an AI robot, with the help of the simulator, I think it's easier to switch the task for this robot. So maybe today, the robot can perform a welding task, and then maybe tomorrow, you switch the AI model, and it becomes a cutting robot, for example. So that's my view. Thank you.
Thank you, Director Huang. And I'd like to invite James. James, would you like to briefly introduce yourself first?
Hello, everyone. My name is James Chen, and I'm the sales representative for Landing AI in Taiwan. So based on this topic, in our perspective, the first smart manufacturing, whenever we landing AI, we approach with the new customers that there might be a couple suggestions that we will definitely provide to the customer we are facing. So talking about the AI transformation for their factory lines, the first thing we will talk about is to find the right scope. Because there's also many different type of questions or problems that we might face in a factory or in a production line. But is all the question or problem could be solved by AI, or they might need other solutions. So find the right scope to the right solutions. That will be the first thing that we need to talk about. So as long as we find the right scope that could be solved by AI by deep learning, the second thing is that we will suggest the customer to start small, to find a small project that to try to evaluate on the data they collected with the small projects, to do a POC to make sure that the function could work, to let the customer understand the concept that we could do for them. And at the same time, they could also do an ROI calculation to understand that what kind of benefit that our solution could bring to them for the AI transformations. So once they can understand those concepts, like the scope and the concept and the benefit that we could bring to the factory line, then that will let them know the value of the smart manufacturing. So that's my point.
Thank you, James. And Jack from Rockwell Automation, would you please also share your point of view?
Okay, from my point of view, the foundation for smart manufacturing will be data standardization. So with data standardization, all of the data is on the same page. So from the research, I think 80% of the time when we're doing the AI project is to do a data preparation. So if we can provide the right data, then we can lower down the total cost of ownership, which can make the smart manufacturing more workable. That's from my point of view.
Thank you, Jack. And our Chairman Chen, anything you want to amplify?
Yeah, I think for smart manufacturing, flexibility is definitely a very important aspect, especially compared to traditional type of manufacturing where people are talking about scale, large volume, large volume production. Nowadays, people are looking at more and more small batch type of production. So definitely any type of intelligence, whether this is data, comes in the form of data or image analysis, anything that can further add to the flexibility of a system is definitely a very valuable thing. Yeah.
Thank you, Chairman. And David, anything you want to add on?
Okay, I think we're all talking about Industrial 4.0 for like 10 years, but I think most of our companies are just far away from the Industrial 4.0 because it's not easy to get all the information together. I think most of small company or medium company still struggle on how to go to the Industrial 4.0, not even talking about the smart manufacturing. I would suggest that from the point of view of the vision, like we use our camera to record every important moment in our life. And every product in the company also deserve the same thing. Try to use camera to take every shot of your products to make your product traceability, to record all the recipe parameter of your product or your process. So I think do this kind of fundamental thing can help you to create data, to collect data, and you will have more data for further AI analysis, for further performance improvement. That's all I think about how to make the manufacturing smart. We should start from gathering data.
Thank you, David. And our second topic is about sustainability of smart manufacturing. So in your opinion, is AI going to be the core of Industry 5.0? And how can we help solve various challenges we face by AI projects? So may I direct this question to Director Huang?
Okay, thank you. So let's talk about the sustainability. I think efficiency is one thing that we need to consider. The efficiency, if we increase the efficiency of a production line, then we don't manufacture that long working hours that can save some money and also save some energy and maybe reduce carbon emission. So I think efficiency is one point that can be achieved by the AI techniques. By better tuning parameters or better configuration of the manufacturing line, we can increase the efficiency. Secondly, I think it's about the quality. If we also increase the quality of the product, then we can reduce the waste or NG product. For that, we can also save some energy or for the environment. So that's my view. Thank you.
Thank you, Director. May I invite James to share your perspective?
Sure. Talking about the sustainability, about the manufacturing, I think the topic we will definitely have to cover will be the green manufacturing. So about green manufacturing, the thing that we need to do is cutting the waste. Because as we can see, some of the manufacturer around the world, when they are trying to deliver a very good result or good products to their customers, to earn their trust, to build the trust with the end customers, that they will definitely make sure that the product they deliver is good. So before the product being shipped out from factory, that they will try to manage the escape rate or the overkill rate for the production lines. So sometimes they might try to lower the escape rate and try to deliver the good part out. But on the other hand, as long as they lower the escape rate, trust me, the overkill rate will just get higher than what we expected. So if we could involve some other solution like AI visual inspection into the production line, we could set up the standard for them to inspect the product, to filter out the good parts and the NG parts. So as long as that we can have that in production line, we could totally cut down the loss for all the products which we might think is a bad part before. So that could achieve the goal for sustainability for the smart manufacturing. Thank you.
Thank you. And Jack, how do you think about sustainability on smart manufacturing?
Okay, I think the key topic for sustainability on smart manufacturing will be how to expand human possibility. Because nowadays we can find there's a lot of tools that can save your workforce from dumb, lousy jobs. So how to make your personal and workforce to do a better job is the key topic in this way. And also, for example, if you are doing the ESG, you need to evaluate your energy consumption. You need to evaluate your EHS system, which requires a lot of lousy job to do the data integration. So a better way to do that is that we systemize, we make it standardized, and let everyone in your plant can do the job. Then we can expand the human possibility to make sure everyone is on the same page. That's my answer.
Thank you, Jack. And Chairman Chen, as a top management, would you also please share your perspective about sustainability on smart manufacturing?
Yeah, basically, if you look at both from data and from image vision point of view, there's a lot of talk about predictive maintenance, leveraging data to cut down, to fine-tune the parameters, and a lot of that has to do with getting the optimized result, and getting that optimized result means that you probably don't need to have as much resource input as before. Same thing with image analysis, defect inspection. If you say, just for example, if your line is producing a lot of gadgets a day, and then the moment you figure out, hey, there's a lot of defects coming in this batch, rather than continue to let it run, you know ahead of hand, hey, this is where I should stop and now inspect. So we actually see quite a bit of that in real life setting. Yeah.
Thank you, Chairman. And David, anything you want to amplify?
Actually, I'm quite agree with the Director Huang, the comment from him about the efficiency. I think the concept, the mindset of the Asian manufacturing is like we want to cost down. We want to cost. We're down the cost about the laboring cost, about the component cost. But right now, we needed to think about the efficiency up. We needed to think about make the product lead time efficiency, make the system integration, automation integration efficiency, make your production line cycle time efficiency, make your trenching line efficiency. We try to make everything efficiency up to improve the manufacturing performance.
Thank you, David. And our third topic is about the suggestions for Taiwanese manufacturers' AI smart manufacturing technology. How do you think that we can export the technology to the United States? May I direct this question also from Director Huang?
Okay, thank you. I think the Taiwanese engineers are really good at ICT technology, and also this right now the software plays more and more important role for manufacturing or even the robotics. So I think first of all we can use our strengths like the software engineers, and we can put our software for the AI or machine learning. I think Taiwan is really move really fast in the machine learning and AI techniques. So together with this, and then we can combine robotics and also our manufacturing experience, the export to the US. I think it's a good move. And secondly, I think our Taiwanese manufacturing, there are really a lot of domain know-how, which I think it's the most valuable knowledge. How can we convert or collect this knowledge to an algorithm or a machine learning model? And then I think that's the strength can be our advantage, even not only in US, but also in other countries. Yes.
Thank you, Director. And James, how do you think we export our AI technology to the United States?
I think Taiwan is the land that has the most diverse industry and many kind of know-how and technique for smart manufacturing that nowhere else does. So based on our experience on working with a local company, like no matter in conventional industry or like manufacturing industry or even in semiconductor, they all have their own know-how and their technique that how to make all the manufacturing even better. So I think we could export those kind of experience and knowledge to other countries, like for example, U.S., that they might have something like car automotive manufacturing in factories, that they could reference some of our experience in Taiwan, like we have the light out manufacturing or like the OEM manufacturing. Those kind of experience could be exported to those kind of automotive factory as well. So take our own company, Lending AI example, that our local team, we have a lot of experience in working with a local company, and we could always share those know-how and those experience to our U.S. team. So our U.S. team that could share those know-how and experience to co-work with their U.S. customer as well. So I think that's a very good way that we could explore that to the U.S. team. Yeah, thank you.
Thank you, James. And Jack, would you like to add on the suggestions?
Sure. I think the Taiwanese company, they need to break down the domain expert, the decision-making process into their AI product. Like in US, there's an excellent company like Lending AI. They have a universal platform that can analyze the data through the AI technology. So I think like Solomon, they do a very good job because they put the like a domain expert, the decision-making process. They know how does the domain making decision, and they put in with AI and integrate them together. I think it can build the right technical barrier and to make them success.
Thank you, Jack. And Chairman, I think Jack gave a lot of compliments to your company.
Thank you, Jack. Well, from my perspective, and this is actually coming from our own experience, the biggest bottleneck when you are trying to export to advanced countries like US and Europe is not so much in technical aspect, it's in the marketing aspect. In all type of automation products, it's not the same as selling PCs. You rely on a lot of system integration works. That means you need to have a local SIs complementing your works. But these SIs the SIs industry is very fragmented. They are spread out across different states, across industries. You know, some SIs only focus on certain industry. Some SIs only focus on certain states. This is the same no matter whether it's US, Europe, or in any other advanced countries like Japan. So how do you, and this is probably even more expensive than then your R&D. It's a marketing money that goes in. How do you get to the right SI that's willing to work with you and they are capable of integrating your products? So that's probably the single biggest bottleneck to do export.
Thank you, Chairman. And David, anything you want to add on?
Before export things to United States, I want to say I also import some important thing from United States. Yeah, we're good partners. We are good partners with Intel. Like for our AI solution, we have a reference design from Intel, and we use their library, and we try to use our capability for system integration, for software architecture. We make it as a ready for market solution. I would say United States and us are work together. And speaking of cloud export to United States, I quite agree with Johnny's comment. Like we make a product here, and we need their system integrator there to help us to do the last mile to the end customer. So how to cooperate with the system integrator there is the most important thing for us. Find a good partner and make your product modularized for them to easy to use. Okay, thank you.
Thank you, David. And thank you all for sharing so many insights. I wish we could have more time, but actually time's up. So please give them a nice round of a big applause. Thank you. And our panelists, please remain on the stage. And now I would like to invite CEO to take a photo. We present the appreciation. Okay. I think we have an appreciation session. But the time is very limited, so maybe just shake hands. Yep, yes, please stand up. So, yep, just a photo together. Our small gifts are arriving there. Vivian, would you please? So, ladies and gentlemen, thank you all for coming to today's conference, and I hope you all enjoyed today's conference with so many insights. And our panelists, please return to your seat. And if you're interested in any company today, please check the event website with their information. And you'll also find the YouTube live streaming video as well. So I wish you all stay safe and stay healthy. Bye for now. See you next time. Bye-bye.